Okay, so this first one, this is question number 3 from the homework, and so it's asking us to determine which double identity replacement is best slash accurate choice in solving the equation. And so really, you could try a couple different ones and they'll work, but the easiest one is what you want to do is you want it to match up with what the other side has there. So when you look at your double angle, well, actually for sine in this case, it looks like we only have one option, and that would be, I'm going to write it down real quick. So sine of 2x in this case would be 2 times cosine of x times sine of x. And so actually that's not an option. So in this case, it's going to have to be none of these. And so I can kind of see why you pick the one below. But in this case, looks like it's going to be none of these. Now let's go ahead and look at number 4 that you sent here. This looks like we're going to be dealing with the quadratic, and so first thing we want to do is set it equal to 0. So what we'll do is we'll add that cosine of x squared to both sides. So we end up with cosine of x squared minus 3 cosine of x, put that in parentheses, minus 1 equals 0. And so we're looking for the interval from 0 to 2 pi. And ideally, what you'd want to do here is try to factor it. So if you look at this, it's kind of the same idea of x squared minus 3x minus 1 equals 0. But the problem is you're trying to figure out what would multiply to give you -1, but then add to give you -3. And it's not that it doesn't exist, it's just not very easy to come up with those values. And so what we have to do is the quadratic formula. And so with the quadratic formula, typically it would be x equals, and we'll write that formula out in a second. But the difference is I have cosine of x, and so that's what's going to be there on my left side. So we're going to have cosine of x equals, and then the quadratic formula is -b plus or minus the square root of b squared minus 4ac, all divided by 2a. And I took a peek at your work, and it looks like this is what you were doing. So you're on the right track. Let's go ahead and see how this algebra turns out, and then we can kind of, it's probably going to have something to do with the reference angles, but we'll see. So that will be my A, B, and C. So cosine of x equals -3. So +3 plus or minus the square root. -3 squared is going to become 9 minus 4 times a times c. So that's actually going to become a +4 right there. And then all divided by 2 times 1, which is 2. So I'll do this part quick since I know you've got this already. So let's see. So 3 plus or minus the square root of 13 over 2. So looking back at your work, I noticed you did have a little mix-up on your signs here. Let me make sure I don't have a mix-up. Okay. So yeah, so what happens here is when we add that x squared over, it becomes positive. And so yeah, everything looks good here. So probably a little mistake here, which is better. A little mistake's better than a big one, right? So, all right. So what we're going to do here is I'm going to put this in the calculator. All right. So I'm going to have to take the cosine inverse. Let me make sure I'm in radians, actually. I need to make sure I'm in radians. Okay, good. I am. So let's see. Cosine inverse. I'm going to type this whole thing in there. Well, I'll do the positive first. So 3, oops. 3, and actually I'm going to have to put double parentheses here. So let's see, 3 plus the square root of 13, close it, all divided by 2. So I don't know what calculator you're using. This is kind of an older TI-83. But I need to, basically what I did was I need to make sure I got the numerator in parentheses so that it's all divided by 2. So that's why I did that in my calculator. And let's see, go ahead and press enter. Oops. Okay, so that must be outside of my domain. And so let's go ahead and try that with minus now. So I'm going to change that to minus. Let's go ahead and see if we get up. There we go. And let's see. I think we're supposed to round 2 decimal places. Let me double check that. Okay, so yes, 2 decimal places. So let's see. That's going to be, oops. Or actually, let me go ahead and write that down anyway. So we did cosine of x. Or actually, let me just go ahead and write the notation for this. So we have x equals the cosine inverse of 3 minus the square root of 13 all over 2. And give myself a little bit more room. And so let's see, we got 1 point. That's going to round to 1.88. So 1.88, and that's radians. Okay, now to kind of give you a visual of what's taking place here. So on the unit circle here, so this is a negative ratio right here. 3 minus the square root of 13 is going to cause this value in here to be negative. And so cosine is negative in quadrants 2 and 3. And so, you know, pi is right here, which would be like 3.14. So like 1.88 is probably, you know, I'm just going to estimate, but it's probably somewhere about like right there, right? So that's the angle that's we're looking at right there. That's 1.88 radians. You know, it's a rough sketch. And so that's the x value right there. And so that same x value would also be the angle right here, that angle. And I fix that arrow. I guess I should point it the right way. The first one. There we go. Okay. So that first one is 1.88, and so I need to keep going around, but that's the same distance right here as going negative 1.88. So what I'm going to do is a full revolution is 2 pi, right? A full revolution is 2 pi, which is the same thing. Well, I'm going to have to put it in the calculator. What I'm going to do to figure out that other angle right there is I'm going to have to do 2 pi, and I'm going to subtract 1.88. And what that does is it gives me that positive angle because that was the parameters. The parameters was between 0 and 2 pi. So 2 pi is that full revolution, and I'm going to subtract off 1.88, and that will give me that second angle right there. So let me go ahead and grab my calculator. So let's see, 2 pi, and then minus 1.88. And so we're going to get 4.40. So 4.40, and that will be my other angle right there. Okay, I hope that helps.